Hello everyone, welcome back to the multiplayer FPS tutorial series, and today we're going to be covering shooting, damage, death, and respawning. So this is going to be a long video. We're also going to be using some more advanced C# features like inheritance, abstract classes, and interfaces, as well as learning how to synchronize state in Photon using RPC calls. So the first thing I want to do here is rename the guns in our player controller, because right now we have gun 1 item and gun 2 item, and that feels a little uninspired. So I'm just going to click on the gun 1 item here and press F2 to rename it, and I'll name this one rifle, and then I'll press on gun 2 item F2 to rename, and we'll name that one pistol. Then I'll rename the child of the rifle to rifle object and the child of the pistol to pistol object to keep it consistent. Next we're going to rename our gun info scriptable objects here. So gun 1 will become rifle, gun 2 will become pistol, and then we can rename them in the inspector field here as well. Now that we've got that out of the way, I want to give you a brief lesson on abstract classes and how they can save us from hours of time and messy code. When I look back at the inventory systems for the games that I made, everything is hard-coded with if statements. If I'm holding this item, do this. If I'm holding this item, do that. This works alright on a small scale, but when you start adding more and more items, the code quickly becomes messy and impossible to work with. The solution to this is using abstract classes and inheritance, and letting each item control itself. To demonstrate how they work, here's a diagram. We start with the item class. The item class will have an abstract method in it called use. Whenever we want to use the item that's in our hand, we can just call the use method on it. Then we have a class called gun. What's important about this class is that it inherits item, so it actually has access to that use method. The gun class will be the parent class for all guns, and will manage things in the future like ammo consumption and recoil. For now though, it's just kind of there. From the gun class stems a class called single shot gun, which we'll use for every gun that shoots a single bullet at a time, so like a rifle or a pistol. For guns that shoot multiple bullets at once, we'll have another class for that called shotgun. And what's important here is that in the single shotgun script or the shotgun script, we can override the use method from the abstract item class. And so whenever we want to shoot a gun, all we have to do is call use on the item class. And the real beauty in this system is that when we want to add more weapons, we can easily do it. And the player controller never needs to know about these new items. It never needs to know how they work. All it needs to do is call the use method, and then the classes will handle it however they want. So we could add a whole new melee subclass and then put a knife under that, and to attack with a knife all the player would have to do is call the use method. If you're still confused, I included a video in the description which goes over this topic extensively and is very helpful. Now that we've gone over our structure, we can start to implement it. I'm going to remove the item script from both of our guns because we're going to turn it into an abstract class. Let's open it up in Visual Studio, and then at the top we can just write public abstract class. Next we'll add our use method, public abstract void use. And this won't have any implementation at all, it'll just be a semicolon at the end. Now back in Unity, let's make a new script called gun, and open it up in Visual Studio. Then we're going to delete all of this because this class is actually just going to be pretty empty. It's going to inherit from the item class, and we will make it an abstract class as well. Next we'll add a public abstract override void use with a semicolon at the end. In the future, this will take care of recoil calculation and ammo consumption, but right now we're just going to leave it like that. Next we're going to create our single shot gun script. Now we can open it up in Visual Studio and inherit from the gun class. We can remove all of this junk because all we're doing right now is overriding the use method. So we'll write public override void use, and then this time we'll use curly braces because we're actually going to put stuff in here. For now, let's just use a debug statement so that we can make sure what we've made so far works. Let's log a new string and we'll combine using gun and then the item info.item name so we can detect which gun we're using. As of right now though, this isn't going to work at all because we're not ever calling the use method. So let's open up our player controller class, and then right below where we're equipping the different items, we'll say if input.get mouse button down 0 items at item index.use. Now if we click with our mouse button, it'll use whatever item is in our hand. Let's head back into Unity and add this new single shot gun script to both of our guns. We'll also need to reassign the game object and item info we had before. Let's click on our player controller because we're going to have to re-add these to the item array. Now that that's done, we can start up the game and join a room. If we click with any of our guns, you can see in the console that it says what gun we're using. So if I click with the rifle, it'll say using gun rifle, and if I click with the pistol, it'll say using gun pistol. Now let's implement some actual shooting. I'm going to go back into the single shotgun script. Let's make a new method called shoot. We'll replace our debug statement here with a call to our shoot method. In our shoot method, we're going to make a new raycast, and in order to do that, we're going to need a reference to the camera that the player is using. So let's make a serialized field camera cam variable. Then in shoot, we can make a new ray using the cam.viewPortPointToRay function, and we'll pass in a new vector 3 with the x and y being 0.5. This means we'll make a new ray that comes straight out of the center of our screen, so that we'll always shoot in the exact middle of our screen where you want to shoot. Next, we'll set the origin of the ray to the cam's position, and then we'll actually shoot it. So let's start a new if statement here. If physics.raycast, and then we'll pass in the ray as well as out variable, out raycast hit. Then in this if statement, we'll just log if we hit something. So we'll write debug.log, we hit, and then we'll add to that the hit.collider.gameObject.name, just for testing. Now when we head back into Unity, we're going to have to make sure that we assign the cam variable on the rifle and pistol to the player camera. If we start the game up and create a room, you can see that anything we click on, it'll print the name of to the console. So if we shoot at this cube, it'll say we hit cube. If we shoot at the ground, it'll say we hit plane, and then we can do this for the others and see that it correctly prints the name of the object we hit. Now that we know the raycast is working correctly, we can start working on actually damaging things. So to do that, we're going to make a new script called iDamageable, and this is going to be an interface. So let's open that up in Visual Studio, and then we're just going to delete everything here. And at the top, we're going to write public interface iDamageable. And in here, we're just going to put one method, void take damage, and in that we're going to pass in a float damage. And this is similar to the abstract class where there's nothing actually in the function, it's just a semicolon at the end. In our single shot gun script, let's replace the debug statement with hit.collider.gameObject.getComponent iDamageable, and then we're going to put a question mark after that so that the next statement only gets called if an iDamageable is actually on that object. Take damage, and then we're going to pass in the damage that the gun does, and we don't actually have this yet, so we're going to have to go to our gun info script, and in here we're going to add a new public float damage. And back in our single shot gun script, we can just pass in the damage here. So to do that, it's going to be a little funky. We're going to have to cast our item info into a gun info, and then we're going to take the damage value from that. And the reason we have to do that is because the item info class doesn't have the damage value, the gun info class does. So we just have to cast the item info class into a gun info class and take the damage from that. Now if we head back into Unity, we can set up the damage values for the rifle and pistol. I'll set the rifle to be 50 so it kills in 2 hits, and the pistol will be 25 so it takes 4 hits to kill someone. Now we need to make it so that the players can damage each other. Open up the player controller script and add iDamageable at the top after monobehavior pun callbacks. It's going to give us an error because we haven't properly implemented the interface yet. To do so, just go down to the bottom here. We'll add the function that we created in the interface, which is public void take damage, and then we'll pass in the float damage. And just for testing, let's add a debug statement here which says took damage, and then we'll add the damage to that so we can see it in the console. Now if we build the game using Control B, we can test it with 2 clients. And in the editor here, if we click on the other player, we can see that they took damage in the console. And if we use the pistol, they'll take 25 damage. If we use the rifle, they'll take 50. Now what we have so far is good, but nothing actually syncs over the network yet. We're not telling the other player that they actually took damage, we're just displaying that they took damage on our screen. So to do that, we're going to be using something called RPCs. To make an RPC, we're going to add a new function here, and before it we're going to put in brackets pun RPC to declare it as an RPC. Let's write void RPC underscore take damage. We'll pass in the float damage. And then let's replace our debug.log statement here with a call to the RPC. To call an RPC, we can just do pv.rpc, and then we'll pass in the name of the RPC method as a string. Then we'll choose the target of who we want to send it to. In this case, we'll just send it to everyone on the server. And we'll pass in the value that the RPC takes, which in this case is a float damage, so we'll just pass in damage there. Next, we'll write if not pv.isMine return in the RPC function. This will make sure that this function only runs on the victim's computer. And in here for now, let's just put a debug statement and debug how much damage we took. So just to be clear, here's what's going on. Whenever we shoot someone, we'll call the take damage function from the iDamageable interface. This will run on the shooter's computer. Then it'll call an RPC, which will be run on everyone's computer. We use if not pv.isMine return to weed out anyone who isn't the victim, and then we'll sync the damage. Now let's head back into Unity and build the game to test it. Now let's create a room and join each other. Now you can see that I'm playing as the client, not the Unity editor, and I'll move the window over so you can see the console. If, as the client, I shoot the Unity editor player, you can see that they're taking damage. So it's actually syncing from the builded game across the network to the Unity editor. And we can see that we're taking damage different amounts for whatever gun we use. Now we've got the damage system in place, but it doesn't really do anything in the long run. We don't lose health and we don't die. So let's fix that. I'm going to make a new variable here, const float max health, and I'll set it to 100, and it's constant because we're never going to change it. And then we'll say float current health equals max health. Back in our RPC underscore take damage function, we'll say current health minus equals damage to subtract the damage from the current health. And then we can check if the current health is less than or equal to 0, we'll call a function called die. Now let's make that function, void die. And in here, we're actually going to be calling a new method that we're going to make on the player manager, because the player manager is going to handle death and respawning. In order to call a method on the player manager, we're going to need a reference to it. So to do that, we're going to use one of Photon's handy features, which is passing instantiation data into an instantiation method. So first things first, we have to make a variable to store the player manager. And let's just go up to the top and make a new variable, player manager. Now let's go into our player manager scripts. And in our instantiation line of code here, at the very end, I'm going to make a comma, and then I'm going to type 0, which is the group of the prefab, and we don't need to mess with that for now. We'll just leave it at 0. And then we'll add another comma, and here we're going to add the actual parameters we're going to pass into the prefab we instantiate. So I'm going to make a new object array, and in this object array I'm just going to put pv.viewID. So we'll send the viewID into the instantiation method, and then the player controller can read that and find the player manager. So let's assign our player manager variable here, and we'll say player manager equals pv.instantiation data, and this is going to be an array of objects, so we'll get index 0, which is just going to be the view ID we passed in. And then in order to actually find the player manager in our scene, because all we have right now is an int, we're going to use photon view.find, which will give us the game object with that ID. And then we'll do .getComponent player manager. And this is going to give us an error here because it's an object, so we just have to cast it into an int and then we'll be fine. Alright, now that we have a reference to our player manager, we can call a method on it. Let's go back down to our die function at the bottom, and in here we'll just call playerManager.die. Then in our player manager, let's make a new public void die method. And in here, first we're going to destroy the controller that's already in the scene. And to do that, we have to make sure we have a reference to it. So up here, we'll just make a game object controller. And then when we instantiate it, we'll just set controller to be equal to that. And then when we destroy it, we'll just pass in controller. And then we'll create it again using the create controller method. And that's it. And we're done. So let's head back into Unity and build the game to test this. And now that it's built and we are in the game, you can see that if I click on the enemy, they're gonna die and then respawn once they've lost all their health. So if I use the rifle here, clicking twice will kill them in 2 hits, and if I use the pistol, it'll kill them in 4 hits because it does 25 damage and the rifle does 50. And that's it. Right now there's not much gameplay because you always spawn in the center of the world, and next episode we'll cover spawn points so that you can randomly spawn anywhere on the map, and it'll be a little bit more fun. As always, special thanks to my patrons Mikkels, Ojack Frost, Neil, Benzito, Dottie, Mike, Hawk, Orchidy, and XZippyZackX. Thank you all so much.